This is such a nice looking problem from Math Calendar 2025. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So you're watching another episode from Prime Logic. The problem setup is pretty much self-explanatory. So we have two squares here with the area of 9 and 16. On the sides of these two squares, there is a triangle here, and the area of this triangle is 3. So what is the area of this triangle? So based on the first square, we know that the side length is 3, right? Because that's a square. And based on this square, the side length is 4. And now let's draw a line. So we don't know about the altitude or the height of this triangle. But let's draw a line here, and then let's find out about the altitude of this triangle. So we know that the base of this triangle is 3. So we want to draw the altitude for this triangle. So let's draw a line parallel to this side length. So from this vertex, the bottom vertex of this triangle, up to here, let's say, and then they should be perpendicular. So this length is the altitude of this triangle for this side, for this base. So we have the area of the triangle, right? So what is the area of the triangle? The area of any triangle is base times altitude over 2. So we have the area. The area is 3. And we have also the base. The base is also 3. So 3 times something, which is the h, or the altitude, over 2 equals 3. So we know that based on this one, we can write 3h equals 6 and h equals 2. So the altitude of this triangle for this base is 2. So this length here, it is just 2. So what is the next step now? So we found the altitude of this triangle, but what about our goal is to find out the area of this triangle here. So for this goal, so let me just delete this part so we know that the h, or the altitude, is just 2. For this goal, we need to rotate this triangle, let's say this colored triangle, 90 degrees clockwise. So since the two sides of this triangle are based on the sides, are built on the sides of these squares, so if you rotate them 90 degrees clockwise, so this side coincides with exactly the same side, because this is a square, right? So this vertex exactly coincides with this vertex. And if we rotate this part, this side of this triangle 90 degrees, it is collinear with this one. So we have a side length of 3, and we have this triangle. So I know it looks messy, but I just drew it beforehand on a piece of paper just to make it a little clear for you. So what we did is we rotated our initial triangle 90 degrees clockwise. And we calculated in the first step that the length of this height is 2. So if we rotate the same thing, the same shape here, it is also 2, right? So it is interesting. The surprising fact is that, so since the base, so we know that the base of this triangle is also 3, right? So since the base, which is also the side of this square, and it was also the side of this triangle, and we rotated that 90 degrees, they are collinear. They are on the same line. So this green triangle is our original triangle, and the height of this triangle, or the altitude of this triangle, is shared also for this triangle as well. So look at this part. This is the base of the triangle, and this is the altitude of the triangle. So that's now easy. So that was, I think, the most critical and the most, I think, fundamental thing to solve. So we have the base, which is 3, and we have the altitude, which is 2, and the area is just So the area of this triangle is 3, just similar to the previous one, 3 times 2 over 2, which is just 3. So we can conclude that the area of this triangle is also the same as the area of this triangle with different shapes. So that's going to wrap it up for today, guys. So I hope you enjoyed this video. Please write down your approach down in the comments below. Definitely, this is not the only approach. I would like to see your approach as well. And don't forget to share and subscribe if you haven't already. And see you on our next video on prime logic.